In this video, we're going to use infinite series. We're going to use infinite series to prove that e is an irrational number. So to do this, we're going to use proof by contradiction. Remember, the idea behind proof by contradiction is that you start out by assuming that e can be expressed as a fraction. Now, if you can truly represent e as a fraction, if that is true, then the whole of mathematics breaks down. Now, if you can show that the whole of mathematics breaks down, then you have to go back to here and say that you cannot express e as a fraction. If the whole of mathematics breaks down, then you have to go back to here and say you cannot express e as a fraction. So let's just assume that e can be expressed as a fraction. Now, if e can be expressed as a fraction, then this quantity here. So consider this quantity. This quantity here will be a whole number. Will be a whole number. So if you can truly express e as a fraction, then this quantity here this quantity here must be an integer, must be a whole number, because m is a whole number. So m minus 1 will be a whole number times another whole number. The overall thing must be a whole number. So if e can be expressed as a fraction, then this quantity, where you have this thing times this thing must be a whole number. So now, hang on. So now let me think. So here you've got this block multiplying with this block. So we've seen this many times. Turn this e to the power of minus 1 to a series, which we've done many times. So I'm assuming you can do this. So now you've got m factorial, which is this thing here. So this thing here, so basically turn this into a series, which we've done many times, and I'm assuming you can do this. So now so once you've turned this into a series, then we are going to break this series up into two blocks. You've got one block, and then this one goes all the way to infinity. So we're going to break up into this block and this block. So you've got two blocks. Now this times this, this times this, this times this, and so on. This whole thing here will be an integer. So if you multiply this out, so remember we're breaking this up as one block, and then you've got another block here. Combining these together, which is this thing here, well, this thing here will be an integer because, hang on, let me explain why. This whole thing here. So hang on. So you've got one block here, and then you've got another block here. This whole thing here, which is this bit here, will be an integer because so here you've got this times this, this times this, this times this, and this times this. Let's just look at it at this case here. Let's say, remember we said that e can be expressed as a fraction. So you've got one number over another number. So let's just imagine it's 5 over 3. It's not true, but let's just imagine it's 5 over 3. So this m here is 5. So going down here, the reason why this block here must be an integer, must be a whole number, is because of this. It's because of this. So when you get this times this, so remember this is 5 factorial. So 5 factorial over 3 factorial must be a whole number, because 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Then this must be an integer. This must be a whole number. So now let's look at this. This times this. Well, let's just imagine this to be 5 factorial over 2 factorial. So this must be a whole number. 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 So for n being equal to or less than m, then this whole thing here must be a whole number. It must be a whole number. So going back to here, we've got one block plus another block. Now, so this whole thing here will be a whole number. It will be a whole number. So let's call this whole thing here to be capital A. And then so hang on, going back to here, you've got one block here. You've got one block, and then you've got another block here. Combine this whole thing together. Let's just call that whole thing A. Okay, and then the rest all the way to infinity. Remember, all the way to infinity. So the rest will be, well, this is your m factorial, and then this is your k, but then this one here will be k plus 1, which will be this thing here, and then your next term will be this thing here, and then your next term, and so on, all the way to infinity. So let's go back one step. You've got one block, and then you've got another block. Combine this whole thing, that will then give you A, and then the rest will be this thing here, all the way to infinity. So let me give you an example. So hang on. So just imagine that that E can be expressed as m over n, where m is one number, this n here is another number. So when you look at this, hang on, bear with me. So when you look at this, hang on, bear with me. So here, remember, we've got one block, and then we've got another block. So going down here, this is your one block here, and then this is your other block here, all the way to infinity. So we are combining these together, because we know that if you get this times this, it will be a whole number. This times this will be a whole number, whole number, whole number, whole number. So the whole thing here will be a whole number, and then the rest will be this times this. The rest will be this, which is this bit here, and then this thing here will be this, and then this thing here will be this, and so on, all the way to infinity. I will continue in the next video. We are currently here. Okay.